Alright, so we're on the extra practice page. So what we're going to do is a two-step process. So those of you that want to know about space, you're going to need two lines right here. Okay? First of all, we're going to write this like yesterday. We're going to just write it out. If it says 10 to the 5, that means to the right. So starting right here, you go 1, 2, 3, and then I still need to go 2 more places, 4 and 5, and those have to be filled in with zeros. So I'm just going to rewrite that. 3. That's right. 3, 2, 4 with 2 zeros. But this is a two-step process because the directions then said that you should write it in scientific notation. So all we have to do is do that opposite. We practiced both of these yesterday. Now the way it is, our decimal, we moved it right here to the end. So that's where the X is. Where is the decimal now? Yep. That's right. The decimal goes right here. So we rewrite all of our numbers that are not zeros unless there's a zero in between. We write 3, 2, 4. There's no need to put the other zeros there. We put the decimal right here, 3.24 times 10. And now all you have to do is figure out from here to here how many places?
4.
Positive or negative? Positive. From here to the X. That's to the right. Alright, so that's all we're doing today. I'm going to do a few with you. You're going to try some on your own. Number 2. So for this first one, it's not in scientific notation. You can't just put a dot there. You have to deal with what it says over here as well. So we're going to start here where the decimal is. We're going to go to the left. 7 places. 1, 2, 3, 4, 5, 6, 7. That means you put in 3 zeros. And your decimal's here.
What is that?
Those are my zeros.
No. What would you say?
Oh. I would read it. You could read it as tenths, hundreds, thousands, 10,000, 2,800 thousandths, or you can read it as 0.00028. Okay, but that is not our answer. That's not scientific notation. That's standard form. Make sure that I did it right. I didn't have to put the extra zeros there.
Stop saying our middle name.
So, to turn it into scientific notation, we put the X here, and we put our new dot right there. So, we have to turn it into 2.8. Okay, 2.8 times 10. Now, good. I see that it would count 4, but which direction are we going for? Negative 4. Good. Because we're going from this, and we have to go to the left to find the X, so that's negative. Number 3. Start off right now on your own. Write this, the first step. 36 times 10 to the second. Write that out in standard notation. Alright, 36 times 10 to the second, what is it?
3,600.
Good. And now, you have to turn it into scientific notation. So we need to get rid of the decimal that's already there, that's at the X, and we have to put the decimal in the right place. Good. So now it becomes 3.6 times 10 to the positive 3. Good.
Who the heck is that? That's me.
Number 4, on your own, copy it down and write it by moving it to the right 6 places. So how many zeros are you adding?
5.
Good. 5. Because the 2 counts as 1 move, and then you have to still add 5 more. So you put commas every 3 groups of numbers. Okay. Now that's not the final step. They want scientific notation. So here's your decimal. Here's your new point. So now, when you see it next week, don't be confused by all the stuff we do with it, okay? 9.832, now it's times 10 to the what? 8, good. Okay, so we turn that into this. And I'm glad that you're seeing it now because it's going to be mixed in and jumbled in with other problems. And you need to think back to today. You just do these 2 steps, okay? All right. right, try these two. No, one at a time. Try it completely on your own. Go. So was it just a movie?
So you go left or right?
Yes.
And then did you now write it as what?
1.0.
I think that's good.
X.
Damn.
Daniel?
So did you get 0.6821?
Yeah.
Yes. But then you moved the decimal to right here,
Yeah.
and you called out your X. So which direction are you going? Left one place. So it would.
Oh yeah, I put that.
All right. So 0.89 times 10 to the 0. What does that become? 8.9. Final answer.
Again.
But it moves 0.
It was out of this.
Goes nowhere. 0.89. Good. You guys.
8.9. 8.9.
No, it's 0.89. Because it's 10 to the 0. No right, no left.
I say we get rid of cable.
Here is your new decimal. What's it become? 8.9 times 10 to what now? Negative 1. I had that part right. Alright, number 8. So, it goes to the negative 1. Did you get 45.45?
Y'all need to get into your college.
Okay, you guys. Now, scientific notation means that this is gone and your decimal moves here. So is that positive 1 or negative 1?
That's a
Positive 1. Okay, 10 to the positive 1. Alright.
Okay, so for number 9 and 10, try these on your own. Okay, so if you look at number 9, you really don't have to do anything to it. 6.288 already has the decimal in the right place. So if you already have scientific notation, there's no need to make any changes. It would still stay 6.288, and it would still be times 10 to the negative 2. Number 10 is different because the decimal is not in the right place to begin with. Over here, the decimal was right after the 6. Here, the decimal has no number in front of it. So what we're going to do is, first of all, multiply by 10 to the power of 1, which is going to move the decimal to the right one place. So we would have 0.05. But then we have to write it in scientific notation. So we will put our X right there, and we will put our decimal right after the 5. And if you think about it, starting from this dot and going to the X, it would be to the left 2 places. So your final answer will be 5 times 10 to the negative 2.